Okay, so today I'm gonna try to solve this problem 907 sum of subarray minimums. I solved that one maybe even 2 years ago, but now I actually didn't check the solution I did before, so let me quickly read the problem. I'll try to solve it. Let me make it also bigger. I don't know why it's gone. Okay, okay. Yep, something like that. Hope it's visible for you. Okay, so here can okay, sum of subarray minimums. This task is very interesting in terms of like how we can build this subarray minimums. So if you have at least some pointer, like the initial minimums are like 3, 1, 2, 4, and then if we add one more, we should update. Okay, let me think about this. So we have this array. Let's copy that one here. So we have array. It's I know one technique how to build this sub arrays. So you just add one by one. So you start with 3, then you add 1, then 2, then 4, then you again your pointer now starts at 1. So you do and you get the 3 and you move it to the end. Oh, VS Code. So we need to do something like this. It's working now. Yeah, it's working now. So we do 3, 1, 2, and then we have a pointer. So initially we had a pointer starting at 3. Now we have a pointer starting and going back, going to the end of the array, and we go through all this array of elements we already added. We just add 1, 2. We do 3. 3, 1. We do we add like 2, 2, 1. We do 1, 2. We add 4 to 2, 2, 4. And then we again, but we now start with 2, and we go again. We do 1, 2, and 2, 4, 1, 2, 4, and then okay, we start with this one actually. We do 3, 1, 2, 2, and then 1 to 4. And then we end it, and then we start again here and here. We do 3, 1, 2, 4. So we need to add all those minimums. Let me think about, maybe I can do some backtracking there. 3, 1, 2, 4. I would definitely do some kind of sliding window, but like if I do like sliding window from there, here and there, and then sliding like from here and here, and then here and here and here and here, and then maybe I do like 2 sliding window 2 elements, sliding window 2 elements, and then sliding window 3 elements, and then sliding window 4 elements, and every time how many sliding windows will I have? So I'll have virtually how many so array length 3 to the multiplied by 10 to the power of 4, 3 by 10 to the power of 4. So n equals 3 to 10 to the power of 4. If we have this n, so we need all like sliding windows. We have like n sliding windows of the length 1. We have n minus 1 sliding windows with the length of 2. We have n minus 2 sliding windows with the length of 3, and so on and so forth. And we have n minus 1 sliding window equals like 1 sliding window with the length of n. So if I every time, so we have 1, and so if we will have this technique, What's the time complexity gonna be here? And we can have like what we can have a stack, uh, not a stack actually, a DAC. So we have like let's say we have sliding window of length let's say 2. We added 3 and 1, and the minimum here uh, is equal actually to 1. And then we need to remove actually we need to remove 1. Oh, we need to remove 3 and add 2 and still calculate the minimum fast. How we can do that? I have idea of min heap. But every time we're gonna like do this min heap, getting the minimum gonna be of 1, but actually removing and then adding new value. Uh, Adding new value, we should like add it to the bottom and then propagate it to the top, so it's gonna be log n, like whatever we'll have the length log m here. So in this case, when we have like 2 elements, it's gonna be log 2. And then the removing element, what concerns me is like removing element from the min heap. So we'll have to find this element somehow in the min heap, and then we need to kind of rearrange the heap, and it's not that time efficient operation. So min heap probably no. Is there any unique guarantee there? Okay, there can be like repeating values. Oh no. No, there is no condition. So it should be basically, it can be basically anything. If you have a stack, so some kind of stack, and let's say we have like 3 elements, let's say we added like say we have 3, 1, 2 somehow processed, and we need to remove 3 and add 5, and then still get the minimum. How I can efficiently do that? Let's say we have like stack something like this. We see 3, then we see 1. We add 3 to the stack, we see 1. We pop the element, we put 1 in the stack. Then we see 2. We pop the oh no. Let's say we see 3, we pop it in the stack, we push it to the stack, then we see 1. We, let's say, push it to the stack. Then we see 2. What should we do in this case? So the minimum has not changed, but actually we should account for this 2 somehow. So that when the 1 is removed from a sliding window, we should check it back. Like it should be still there. We cannot just skip it. Hmm. So like the brute force solution here, I'm thinking about some kind of optimization, but the brute force solution gonna be like we'll have this length going through the 1 to n. We have this sliding window where we have like in a window we have a minimum, and then if we have kind of a new value, we should go through all elements from the sliding window and add this new value and remove the one that was in the tail. And then the time complexity of this gonna be, so we'll have like n, for the length 1 we'll have n sliding windows, and for the remove, let's say we have remove element and find new max. New max is gonna be like, let's say this is of 1 if it's kind of linked list, and this is next maximum. Let's say it's gonna be of like whatever m size of length. So it's just going through the all values and checking what's the minimum there. So like here we have n multiplied by 1, and then here we have n minus 1 multiplied by 2. On every operation we need to go through all of them and find a new minimum. And then here it's going to be n minus 2 multiplied by 3, and so on and so forth. And in the end we'll have 1 multiplied by n elements to find the common common minimum across all of that. And if you sum that, it's gonna be something like this. Okay, let me, probably gonna be easier to understand. N plus n minus 1 by 2 plus n minus 3 minus 2 by 3 plus 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 1 multiplied by n. And you'll have this n values. Um, so with some kind of sum I from 1 to n, and then here we have n minus I minus plus 1 multiplied by I. So how to assess this? Probably like we need change it 1 and n minus I plus 1 I the I. So we need to basically, this one gonna be sum. We have like one term by another term. So I with a minus sign plus some constant. So it's gonna be roughly C minus I, because n plus 1 doesn't change when I changes. So it's gonna be some, so this is gonna be C minus I by I, this I, and then let's say it's gonna be like Y here. And then we need to find the sum across that. And then I from 1 to n. And we can like approximate that with the integral and take this integral. So here gonna be like the highest term gonna be minus I cube by 3, and then n, and then 1, and then yeah, that's bad. Let's make it better. So like the n plus 1, and then I squared by 2, and then n 1 minus I cube by 3 and 1. So it's gonna be n plus 1, and then n squared by 2 minus 1 minus 1 half minus n cube by 3 minus 1 third. And then gonna be, so basically if I just take the highest term here and here, so it's gonna be n cube by 2 minus n cube by 3, so it's gonna be n cube, so here like 6 3, and then 2 6, so it's gonna be 1 6, n cube by 6. So it's gonna be n cube complexity. So this brute force gonna be O of n cube, where n is 3 3 by 10 to the power of 4. So it's gonna be 9 to 10 by 12, way over what like computers can do. So the computers can do like so this is gonna 10 complexity. Computers can do like 9 like 10 to the power of like 7 or 10 to the power of 8 operations, and the memory is quite similar. Um, so like this one is not acceptable unless I somehow improve I somehow uh, improve this algorithm. Like there are two parts. First part, because I have to do through let's say I improve somehow this instead of like multiplied by one, so minimum selection. Uh, like that, instead of O of 1, O of 2, O of 3, and then O of n, like minimum selection can be O of 1. If I improve that one, then my equation changes to just n minus 1 plus n minus, oh, just n plus n minus 1 plus n minus 3, 2, and then so on and so forth, and then plus 1, and then this complexity, if I sum that, it's going to be O of n squared. And then if I do even O of n squared, I'm still on the like borderline of n squared. So like in case of n equals like 3 to 10 to the power of 4, it's going to be 6, 10 to the power of 8. That is already like time complexity is on the edge of what computers can do within seconds. So let me pause right now. I'll I'll go I'll go and take a drink, maybe coffee, think about this problem again, and maybe I can come up with an approach how I can do this minimum selection more optimal. Also, it seems like this problem is quite like if I check this window is similar to this window actually, but I just add additional element, yeah. And if I check this window, it's also similar to that one. I just add another minimum. And then if I check this window, it's also similar to the previous one. That was one. And again, if I'll have this loop that basically start point, start, and if I go one, like start, all gonna start from like 0, and then I'll start from 1 and do the same, and then start from 2, start from 3, so on and so forth. I can like, but again, if the minimum will be much easier to maintain here. So I'll have just a minimum with a length, like say 1, and then I added another one and check if it's like less than the previous minimum. I add the element to the left, to the right. Let's say we have like this element, like minimum was let's say 3, and we added the additional amount was like 1 here, and so the minimum changes to 1, yeah, and then I add again another, let's say 0, minimum again changes to 0, and then I'm adding again like let's say adding interval like 6, and the minimum doesn't change because 6 is not lower than previous minimum, so minimum stays equal 0. And then I'll do the same kind of procedure, but starting not from index like 0, but I'll start from index like 1 and do the same like window of one element, and I'm gonna expand it to the right two elements and account for the minimum. In this case, it's like O of 1 time complexity to find the minimum, just checking between the variables that's already pre-calculated, and if it's lower, then minimum is updated. But again, this is because I have like n possible starting points, and I'll have like um, initially I have like for the first starting point, I'll have like n intervals. For the second starting point, for the like starting point at 0 cell, I have like n intervals of length 1. For the starting, not like, yeah, I made a mistake. So like for the all intervals starting at 0, we have n options. Start at 0, we have n intervals, like interval with the length of 1, interval with the length of, so like it's like n minus 1 actually, or n. Start, oh yeah, it's n. Starts at 0, ends at 0, starts at 0, ends at 1, starts at 0, ends at 2. So it's going to be up to n minus 1 and start plus 0. So n minus 1 plus minus 0 plus 1 going to be just n. So have started 0 number of them, and that starts all intervals that start at 1 will have like start at 1, ends at 1, and then that up to n minus 1. So gonna be n minus 1 intervals, and so on and so forth. Starts at n, number of those intervals is gonna be just 1, uh, because just one window. And those are gonna be n, and it's gonna be like in the end, it's gonna be like n plus n minus 1 plus 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 1, and then it's gonna be, and they are gonna be here the n, so it's like n plus 1 over 2 multiplied by n over 2. So the total time complexity gonna be O of like n squared by 2, just O of n squared. That's, again, I don't like this one, but I assume there is no I don't know, might be not. Let me pause the video, I'll go drink a coffee and I'll start coding. I'm already like 52 minutes into the video. No, 34 minutes into the video. Yeah, so it's again gonna be maybe fail. Um, so I'm back. Let me try to code. I'll start coding this question. Maybe like I had like two ideas. The first, like just a summary. The first idea I had like it was a brute force approach. I figure out that like the time complexity is that gonna be n cubed over 6. Definitely not within the time bound, within the like limitations they gave us. They give me for this problem. So I I have another approach that like somehow similar, but that approach is like has O n squared, and like time complexity and the space complexity gonna be like just constant space complexity. But again, O of n squared, giving this time bounds. I wonder if there are any kind of okay. Let me try coding this question and I'll then. I wonder if I can swap this one, can modify this array 312, but it's contagious. Yeah, if I check this 3 and 4, it's gonna be like minimum 3, but it's not actually included. Yeah, let me try the coding this question, and then we'll see if it's gonna accept that. So I'm gonna start from 4 int start uh, like key equals 0. Let's say we'll pre-save this int a equals and oh x r length length, and then I'll do this I less than n I plus plus, and then I'll have the minimum, and then I'll have the result, and they say module by 10, so it's definitely like so if I do calculator Google calcul if I do 2 to the power of 32 for the integers range, it's gonna be like 4 billion maximum. 4 billion? Yeah, 4 billion. 4 billion. But they say 10 to the power of 9 plus 7. Yeah, so like integer is enough. So I'll have the int and int result equals, let's say we'll have the, let's say we have long equals 0, and then we do this 4 int yacht equals equals I, and then yacht less than n, yacht plus plus, and then we have uh, int min equals r I, and then we have ri plus 1, and then let's say this one to avoid this problem. Min equals mass min, and then r yacht, and then we add result plus equal min, and then we do this result, let's say if result is greater than, okay, result is greater than, so let's say max integer max value. Let's say we have this constant max equals, let's say max value well equals mass power 10 to the power of 9 plus 7, and then we'll have this uh, integer, let's say int. So if it's greater or equal max value, we do the result module by module max value, and we return result. That's it. Yeah, let's do this testing, quickly testing public static void test1, and then we have our input 3124, and then output 17, and input and expected output equals 17, and then solution equals equals new solution equals summary means input, and then boolean path equal output equals expected output, and system out println test1, and then past, and then or otherwise failed, and then I'll say we call here it. Okay, let's quickly check 3124. For this input 3124, let's say we have here this scratchpad. So 3124, so we have like max, so we're starting at index I equals 0. We get the minimum, so 3. We update the result. So we check the minimum is still 3. Minimum equals 3, result equals 3. Then we do this additional, go to the right, we check 1, minimum is 1, plus minimum stays 1, plus minimum stays 1. Then I equals 1, minimum equals 1, and then here result plus equal 1 plus 1 plus 1, and then I starts at 2, then minimum equals 2, and then result plus equal 2, and then plus 2, and then I starts at 4, and then minimum equals 4, and then result plus equal 4. So in this case we have like 5 plus 3, 8 plus 8 plus double 2, so it's gonna be 12 plus 4, 16. Interesting. 312. So here 5, here 1, 5 plus, oh, here like 6, sorry, here is like 6. 6 plus 3 gonna be 9, plus 4, 11, plus plus 4, 13, plus 4, 17. Sorry, I need to work on my mental math skills. Yeah, so it should pass. So let's run this code, see if it's working. Not really. 5. Here we need to also integer convert to integer. Solution. Okay. Solution. What? I don't know what symbol it's complaining to. Solution sol equals new solution. Does it compile if I remove this one? Okay, that helped a little bit. This also public class solution. Okay, got it. Okay, passed. So let's check if it's passing actually the output here. Yeah, clearly time limit exceeded. That was expected. Because it's kind of brute force and to the power of 4 of 8 in the end. 9, so like 10 to the power of 9 basically, because 9 by 9, 3 by 6 gonna be 9, gonna be 10, 9 by 10 to the power of 8 gonna be basically 10 to the power of 9, and it's already like, it's not, time limit exceeded. How I can improve this one? Actually, if I check my submissions, I guess this one submission was maybe because the same kind of issue. Time limit exceeded. So the question is, how I can, like, instead of doing n squared, how I can do that in the linear time, or at least like log n log n here. How I can do n log n or linear. So if I sort it initially, will it help me? It will basically mess up the problem. All because it's gonna be not contiguous. So if I start building like from the middle, let's say we have 3, we have 1, we have 2, we have 4. Can the 2 be the minimum then itself? If we expand to the left and expand to the right, so it seems like no. So basically the idea is how many like intervals gonna like 3 gonna include that that will keep it like as minimum. So if I have um, let's say we have like three, it's minimal to the left. It's like it's expand to the left like 0, and to the right it's like again 0. So it's in itself, it just can be the minimum of itself. So 1 is actually quite generous. So it can be like expanded to the value can be expanded to the left of the interval containing 1, and to the right, and it can expand to like 1 if it's like is included into the interval. It will basically include itself, it will include all other kind of intervals. um, so we'll have like 1 and to the left and to the right. So like to the left we'll have like itself plus plus 1. To the right we have like 1, 2, and 1, 2, 4, and then 1 itself. And then we have like all combinations for that one. So like to the left and to the right. Mm. So it's 52nd minute of the interview. Interesting task. So I'll probably do something like that. 3, 2. I'll have like this 3, 1, 2, 4, and I'll go through through all elements, and I'll try to do this following, like do this so for 3, how many elements to the right and how many elements to the left are greater than 3 and greater than greater than 3. So in this case, if I go for the 3, I have to the left 0, right 0. For the 1, how many elements to the left and to the right greater than 1? So to the left I have like 1 element greater than 1, and to the right I'll have like 2 elements greater than 1. How many elements I have greater than 2 to the left? Like contiguous. I have 0, and here to the right I have like 1. And to the 4 to the right is like 0, have greater more than 4, and to the left is also 0. So now I can basically say, okay, going again through these elements of the array, I can somehow save it, if I'm not mistaken. So like if 3, then it means that only one interval, like left to the left and to the right. So we'll have this formula, number of intervals where the 3 gonna be minimum. So it's gonna be we need 1 plus left plus right, and then plus left by right, something like that. That's interesting. Let's check this formula because I probably guessed it. So like we have for this 3 we have 0, 0. For the 1 we have 1. Oh, for the 3 we have 1. For the 1 we have 1 plus 1 plus 2 plus 1 by 2. So it's gonna be 1 plus 3 plus 2, gonna be 6. Gonna be 1, 6. For the 2, we'll have 1 plus 0 plus 1 plus 0 by 1. So it's gonna be 2. And then here is also 1. No, something is wrong with this formula. So it should be like for the 1, we have like 1, and then we have like 2, and then we have like 3, 4, and then we have like all the combinations like this and this, and then we have like this and this. So it should be 6. So here is 6 actually. Ah, we should actually multiply by the number itself. So like the formula also like multiply by the IE. So here 1 multiplied by 3, here like 3 multiplied 6 by 1, here like 2 multiplied by 2, and here like actually 1 multiplied by 4. So the end we have this 3 plus 6 plus 4 plus 4. And still, it's still not the answer. So for 3, okay, for let's say for 2, 2 gonna be minimum for at least like 2 and 4. So it's 2, and then 4. 4, 1 by 4, 2 by 2. So this 8. So that's gonna be 8. Okay, 8, 3 plus 6 plus 8. It's gonna be 3 plus 14 is gonna be 17. So this formula is good. And if we can like figure out what the like number of elements to the left and number of elements to the right. So to calculate this formula, we need to just do this one pass. So if we can do this also one pass to figure out like or maybe couple passes, but like constant number of passes in terms of n. If you can figure out like L and R in this case, like number of elements to the right, that's current element gonna be the minimum, and the same current element gonna be the minimum to the left and right. And if I can do that in a like O of n time complexity, then I will basically crack this problem in O of n time complexity. So in order to do that, let me think how I can possibly do this. Yeah, we already 1 hour into this interview. So we can do something like number of elements that there are minimum to the right. Let's say to the left. So we go 3, 1, 2, 4. We have like a stack. We add like a 3 to the stack. And we basically yeah, we added 3 to the stack. We go to the next element. We see that the next element is greater than the current one. So we basically we are figuring out like for the current element, we are figuring out how many elements to the left, how many elements to the left are bigger than itself. So if you have the stack of elements, we add 3, and we check the one. So we add actually also 1 to the stack, like go to the array. We go to the 2, and we start checking if we start checking from basically from the start. If 2 is greater than 2 is greater than 1, so we should basically do what? Deplete the stack. I'm thinking right now, so it seems like if I can like do this efficiently, hold this like fill up this array efficiently left and right, I can basically solve this problem. But I need to do that. So it seems like if I jump to 4, I'm interested into like sp1 and 2. Um, or like let's say we have like -4 in the end. I will be interested in 3, 1, and 2. But I might have removed it from the, if it's like monotonic stack, I might have removed it before because I'm going like linearly. So it seems like I need to find the, so for the current element, like for the, let's say 2, or like, let's say we have this kind of values, like say 6, 7, let's say we have like 5. I think here we have 7, and then say 8, and then say here like 9. For the 7, I need to find the next element to the right that is lower than 7. So if I add the elements 6, 7, 6, we see 6, we add that to the stack. We see, let's say we have like here like 7, and there we have like 6. So we see 7, we add it to the stack. We see 6, we pop it from the stack, and we add like say 6. We go to the 5, we popped 5 from the stack, with 6 from the stack, we add 5. Say we see 9 here. We have 5, we have 9, 5. Let's say we see 8. We see 8. We popped 9, we add 8 and 5. And let's say we see 7. 7, we popped 8 and we add 5. Okay, and like every time we do this pop procedure, we figure out like what's gonna be the lower element to the right for the current element. So we have like we can have like stack monostack stack solution, monostack solution for this problem, and we can go off and to the right, and then we can go backward off and to the left. And then it's gonna be like 2 off n plus that algorithm that I have plus algo, and the complexity gonna be like O of n. Yeah. So let me again program that one. So we'll have this int left equals new int and then we'll have int right equals new int and and then we also have stack integer. That will have just indexes of the values. Stack equals new stack integer. Okay. And then for the import Java util stack, and then we'll have this stack, and then for int I equals 0, I am less than n, I plus plus, and we do this. So we check the stack while stack is empty, not is empty, and stack. So it's like minimal. So I'm wondering, should I include the left bound or like greater or equal or just greater? So in case we spot the value yes, we wanna like in case we have like this like case when we have like all the same values in the array, say 2, 2, 2, contiguous array is gonna be like this, and 2 gonna be minimum for like this array, this array, this array, and then again it's gonna be completely like different array. 2 gonna be minimum here for this array, and this array, and then the right 2 gonna be minimum. Let's we have a different color. This array, and then it's gonna be this color. It's gonna be this color, and there's gonna be this color, and then 2 again, but gonna be minimum for this array, and this array. So and 2, 2, oh, 2, and then here like 2. Yeah, so we need to, if we see the greater or equal, we still need to add that to the array. So if while stock not is empty and stack peak is less than RE, we need to do this stack pop. And then left, we need stack push RE. And then we need to actually stack peak, and then we need R because we're gonna push the index. Stack peak. And then the left gonna be left E gonna be stack size. That's gonna be stack size -1, but I'm gonna put it ahead, so it's just stack size before pushing, and we're gonna push the just index. And yeah, and the same gonna do for the for similar procedure. I'm gonna go from right to left, and -1 I greater than equals 0 I minus minus. Probably we can do like even like 2 stacks here, like stack left, stack right, and unify it, and like don't do this again for loop. But I think it's, I don't know, might be beneficial. More code sometimes is better than less code. And then we'll have this, and then right I equals stack size. Yep, stack size. Okay, and then we go through the for int I equals 0, I less than n, I plus plus, and we do this formula. We have log result. Then we have this formula result. I so that 1 multiplied by AI plus L R L I multiplied by AI. Okay, so just the simple formula AI multiplied by AI multiplied by 1 plus Li plus Ri plus Li multiplied by Ri. Okay, and then if result is greater than this, we gonna module divide. Okay, so this is the idea of this code. Let's check if it runs. Line 25. R. -26. Okay, max value. I removed max value. And we need to convert it to integer. I converted it. Failed. What's the output here? Okay, I'll probably print out the left and right array. Okay. Uh, so for int I equals 0, I less than n, I plus plus. And then I wanna print it out to save the order because not to confuse myself. So L, our left array. So we have left to the left. 1 is 1, 2. Hmm. It should be like 0, 1, 0, 0 for the left array. And for the right array, it should be 0, and then this one 1, and this one 2, and this one 1. So something strange is going on with, am I right here? So it was 0, okay, 0, 1, 0, 0, and here it's like 0, 1, 1, 0, and then 1, 2, 1, 0. 1, okay, that's also not correct. 1, 2, 1, 0. If you do this one, no, it doesn't matter. Should be like this one. So let's check, like we do if stack not, so like we have like this example, have 3, 1, 2, 4. 3, 1, 2, 4. We have stack. Stack is not is empty initially. We do li stack size. Okay, 0. L 0 equals 0. We do next. We do push. We push the I. So we push stack equals just 0. So what we do next? We have I equals 1. Ri equals 1. We check not empty, and we check the peak. Peak is 0. So like array at 0 less than, so like 3. 3 is greater than actually 1, so we don't do anything. We do L1 becomes 1, and we do, okay, and we push, so our stack becomes as 0 and 1. I wonder if like I should do this one. No. Okay. So we do I equals, let's say, 2. What we do here? I equals 2. R2 equals 2. Okay, so we'll keep the 3 there. but we don't need to do that to keep 3 there. So like in this case, we'll keep the um it's weird. Um how I can avoid this situation. So in this case, is I equals 2 array second element is equal to. We do stack pop, so we pop the element. So we pop the element there, and we somehow should. So we'll have this s equals 0, and we don't pop it because like element under index of 0, it's actually is greater than ri, so it's greater than 2, because a at 0 is equal 3. So we keep it there, and that's why we have like 1 here, and like 1 here. And there, this is basically interesting. So monotonic stack, I I have this pattern. So I remember there was a task that was something like next greater temperature, and we would like next greater temperature. This one gonna be like for this day is gonna be like this one, and I know that this task is solvable with monostack. And I want to solve it also with monostack here. And it seems like it's a good application, but I cannot wrap my head around like how I can implement monostack in this case. I'm probably missing something here. So I'll wrap up here. I'll double think and maybe issue a second like revision of this problem. Um, it's already like 1 hour 30 minutes. Definitely fail on the interview. So just a short summary. I came up with the approach with monotonic stack that should solve this problem in of and time complexity. I tried to code it. I managed the formula for the like left and right, but I don't kind of manage to get the monotonic stack working in this case. Probably I'm missing some uh, detail, and here in implementation I need to kind of account for this tail and like drop it from the stack in case we have this we start dropping it. I need to drop it all of it. um, yeah, so it's kind of maybe I don't need a stack here, but maybe just array, something like that. Yeah, and if manage to manage to make it work, I can solve this problem often. Otherwise, I spend a lot of time trying to codes O of n squared. Like first explained why this is n cubed and why it's not working. Then I managed to find the O of n squared solution here, but and also programmed it, but it was time complexity like a time limit exceeded answer, and that's basically a short summary of this kind of solution by me today for this problem. Sum of subarray minimums 907. Yeah, that's all. Hope you enjoyed it, at least my stream of thoughts.